All right, so I have three liquids, and the best viewing would definitely be the flat screen up top there. Now, in this demonstration, I'm going to test how well these liquids evaporate. Different liquids evaporate at different rates. We already learned that every individual compound has a unique set of properties, and one of their physical intensive property is their boiling point. That's the temperature at which they change the phase. We've already learned the temperature stays constant because the energy taken in is being used to separate and make them move faster. Kinetic converted to potential. So what I'm going to do is take these three liquids and we're going to observe who evaporates the fastest and make some observations regarding how fast they evaporate, and two, the forces of attraction between the compounds. Now what I mean by that is, we're going to use this word intermolecular attractions. These are now not bonds. These are attractions between the molecules. So if I have some water and I want to know what keeps water together. Now it shows, and you might get confused that that's showing a bond, but that's not a bond. That's an attractive force. We'll later learn that's called an H bond, which is an attractive force. But water sticks together. You know that. Why does water stick together? Because when you pour water, do we pour one molecule at a time? No, you pour one, it grabs its friends and more water. So when you pour water, you can see that it grabs on. Water sticks together like most liquids. What keeps water molecules together and prevents them from flying around as a what? As a gas, okay? What keeps them from flying around hundreds of miles an hour are the attractions between water molecules. Now think with me. If those intermolecular attractions, if those attractions between the actual molecules are strong and or if they're weak, would that affect how well they separate into the liquid phase? Would that have any bearing on how well they separate? How strong they stick together? Yes. So let's watch. I'm going to take these three liquids and smear them. My left finger here is acetone, middle is ethanol and water. Look very carefully. Okay, who clearly evaporated the fastest? Acetone, otherwise called propanone. Clearly, the amount of separation from its molecules into the gas was the best. Now, we have a word that describes how well something evaporates. We call it vapor pressure. Now, think with me for a second. I've got liquids. If they evaporate easy, overcome the attractive forces, they would come out of the top of the beaker. Think with me. Think of the beaker being right here. So if I'm able to escape these attractive forces and leave the beaker, I would have a force hitting my hand on top. You know this because the top of a what? Boiling water rattles. So vapor pressure is the force due to molecules escaping or evaporating. Who had the greatest vapor pressure at the same temperature? All these three liquids are at the same temperature. Who has the greatest amount of force due to molecules separating into the gas phase? Acetone, correct. Now, who's in second place? You may think water. It looks like it's smaller. But when we inspect it, get very close, what we're going to see is that water actually is beating up. Does it look like water is as flat as the other one? No, in fact, I don't know if I can show you this, but water is actually beating up. Okay, so what happened was, and we'll do water side by side again. Watch water. Watch it beat up. What's it doing? Right. So it looks like it's disappearing, but what's it doing? It's attracting each other and beating up. So you may think water is disappearing first, but it's not. Now, if I zoom back up, let's look at the other two. Who's actually disappearing? This is water. And who's in second place now? Who's disappearing? The ethanol. If you look lower, you can see that it's clearly leaving. It's disappearing. So who has the second most highest vapor pressure? Ethanol. And water, you can see that the ethanol is clearly evaporating. The water is not evaporating. So let me ask you this question. Of the three liquids, who has the greatest, strongest intermolecular attractions that's preventing it from evaporating? Water. Who has the weakest? That's why. Okay, so you can see that the ethanol is evaporating. Good stuff. Let me ask you a question. Of the three liquids I tested, who do you think needs the greatest energy? Who has the highest heat of vaporization? Who requires the most heat to vaporize? Water, because it's holding on to what? The tightest. Who has the lowest heat of vaporization? Acetone. You understand. Very good. Now, last question. Who has the lowest boiling point? Who requires the least amount of energy to reach its boiling point? The acetone, because it evaporated faster. We'll talk more about that. Water has the highest. Water is resisting evaporating. It's beating up. Okay? So, we know that acetone, and we know that ethanol were the winners. Let's take the two top winners, or the top winner, acetone, and compare it to liquid nitrogen. Okay? So I need some help here. Reese, come up. Now, I'm not going to dip my finger in liquid nitrogen for obvious reasons. So, Reese, here you take this. Just pour it where it says N2 when I tell you. Ready? We'll do it at the same time. Okay? Let's see who evaporates faster. Okay, ready? On three. 1, 2, 3, go. Okay. I think who won?
I don't know.
Well, what happened is we froze the acetone. Ready? Go again. Go again. 1, 2, 3. Clearly there's some acetone left that froze. But clearly I think the N2 evaporated faster. Whose heat of vaporization is the smallest of the four that I just tested? Liquid nitrogen. Who has the lowest boiling point? Because it requires the least amount of energy. Have a great day.